All right, now we're going to take exponential functions and start to actually write their equations. So you start with this review of a table. Go ahead and come up with the equation for this table. Is it linear or exponential? So you know that by figuring out what's happening here. Looks like you're timesing by 4. So you are using the model y equals a, b to the x. And again, the a value is the y-intercept. The b value is what you're multiplying by every time. And so you have the equation for this chart. 4 times 4 to the x you could write as 4 to the 1 plus x power, but you do not have to do that. If you want to just leave it 4 times 4 to the x, that's fine. All right, so now we're going to move on. You can see this was a delta math problem, so that's something you're going to have to be doing yourself eventually. But here is 2 examples of a ring doubling in value and increasing by 20% each year. So here are examples where you're going to be, when you see the word doubling, you already know the growth factor. Okay, when you see doubling, you know to put a 2 as the growth factor. And the initial value, I believe, was $100, so you're done. It's 100 2 to the x, which is the same as ab to the x. You cannot make that 200 to the x power. It does not reduce like that because the x power is only for the 2. The next problem, though, is new. Okay, the next problem, it says it appreciates by 20%. So instead of writing a b, you have to write 1 plus or minus r, because the r is an interest rate, like at a bank. So your r is 20%, which as a decimal is 0.2. So to appreciate means to go up. So you're going to add to this is basically 1 is 100%. You're going to add 20%. So when you increase by 20%, you're taking 120% of the number, and the initial value, I do believe, was still 100, so that's still the number in front. All right, so instead of 100 times 2 to the x, it's 100 times 1.2 to the x. This 2 right here represents doubling. 1.2 represents a 20% increase. If, for instance, I said it depreciated by 20%, okay, if I said depreciate, then this number would be 1 minus 0.2 if it said depreciate. So that's why it depends if you're going to use plus or minus. So I will show you that here. Another delta math question. An element with mass 490 grams decays by 28.6% per minute. So how much is remaining after 16 minutes? So you're going to start with, I don't see the word doubling or tripling, so I'm going to use the 1 plus or minus r instead of a b, because I don't have a set doubling or tripling phenomena. Okay? The a is always what you started with, so it looks like we started with 490. To decay by 28.6 means you're going to take 100% and subtract 0.286. So the minute you see the minute you see decay, you know you're using subtraction. If it had said to increase by 28%, you would have used a plus sign. Okay, so basically this comes out to be 490 times 0.714. So you're basically taking 71.4% of 490. Now it does say round to the nearest tenth, so we'll say 349. It looks like that would round to 0.9. That's a little sloppy. Sorry, I'm not writing very... All right, so this approximates to 349.9 grams. And that's how you would put that in delta math. So remember, if it says decay, you're going to use the minus sign. If it says growth, you're going to use the plus sign. All right, so this one, they give you the equation. You'll notice that this value is less than 1. So you already know it's a decay. So that number is 100% take away something. So what you're going to do is you're going to take 1 minus r and set it equal to 0.292. Okay, and basically that means 1 take away 0.292 is R, if 1 take away R is 0.292. Okay, so R is 0.708. So determine the percentage rate of increase, so that is 70.8%. Looks like it's a decrease, right? Because it was going down. So if you don't have a 2 for doubling or a 3 for tripling, you're always using this 1 plus or minus R. We can tell the initial value is 23, and we can see that if you get a 0.292, it dropped by 70.8%. All right, and then finally, these four would have been on a pair check. We would have done together in class. If something triples, I see the word triples. So I'm going to go back to the easier formula, AB to the X. It opens with a price of 230. So where does the 230 go? It goes in for A. You don't really need the 0, remember. Tripling means the B is 3, and you're done. Now, if you want to do it for 5 months, you're basically just doing 2.3 times 3 to the 5th power. Okay? So you can certainly try to put that into a calculator as well, and make sure you get 558.9. Because it's money, you should put a 0 on it and a $sign. Okay? All right, this number 2 says a certain stock opens at a price of a penny and it doubles every day. What is the value after 29 days? Okay, so the initial A value is a penny. B is what's happening, doubling. And so we're talking about 29 days later. So 1 penny after 29 days of being doubled is huge because it's an exponential model. It's actually, I think it's like 5 million. Yeah, 5,368,709.12. So just taking 1 penny after 29 days becomes 5 million if you were to double it every day. So you can see how exponential modeling grows things very quickly. Last two. Here we have, it doesn't say that it's doubled or tripled. It says it appreciates by 15%. So here's a model where instead of a B, you're going to have to do 1 plus or minus R. Now, because it's appreciate, we're going to add, and the R is 15%. So basically, instead of doubling as a 2 or tripling as a 3, you're just putting it in as 1.15. Because that's what 1 plus 0.15 is. Okay, and then the original value was, I believe, 1,300. So 1,300 times 1.15 to the X. So 1,300 times 1.5 to the third would give you the answer to that problem. And here you have a 9% interest rate. So you're starting with 20,000 and you're adding 9%. What is 9% as a decimal? And I believe this time you're doing it for 5 years. If you were to do that on a calculator, it looks like your 20,000 would really grow already to 30,000 in just 5 years with a 9% interest rate, which is quite high. I mean, interest rates right now, you borrow money at 3%. Your checking account only has maybe, if you're lucky, a 1% interest rate. So it's hard to find investments at 9%. But if you can, or if you're using maybe the stock market to make any purchases that are growing, it comes out to be right now that 20,000 in 5 years could become $30,000. And it looks like it rounds to 48 cents.